Hello, in this video we're going to talk about how to convert between polar and rectangular coordinate. So let's try this out. I have a coordinate plane here with a vector pointing to a point. Now this point has coordinates, either coordinates x comma y or r comma theta, because maybe this is on the rectangular coordinate plane, or maybe it's on the polar plane, and that's theta, and this is r. How do we go between x and y, r, theta? So first, let's have the assumption that this is, in fact, on the r comma theta, the polar coordinate plane. In that case, if I want to convert to rectangular coordinates, I need to know what is the x and y. And it all goes back to trigonometry. So if I want to find the x value of this point, well, the x value is just the distance over that this point is. So I'm trying to find this length right there in red. And if I'm trying to find the y, well, that's the distance up that I'm trying to find. What do you notice just got traced out here? A right triangle. Yes, where this is y and down there is x. And what do I know? I know r and theta. What is r on this right triangle? It is the hypotenuse. And I know one angle. So this is trigonometry. What trig function should I set up to find x? Well, x is the adjacent side on this triangle. So I know that cosine of theta equals the x, the adjacent, over the r. And I'm going to solve for x, so I get r cosine theta equals x. And I can figure out the value of x then because I was given the point r comma theta. So I know the r value and I know the theta value. And then when it comes to finding y, it's very similar. Sine theta is equal to opposite over hypotenuse. So that means r sine theta equals y. And once again, I am given the r and theta, so I can use that to convert and find my y value. So when I'm converting from polar to rectangular, I just need to know those two formulas to figure out the x value and the y value. That allows us to take a single point and find what its location would be in polar coordinates. It would be in the exact same location right there. It's just how I would label it would be different depending on the r and theta value or the x and y value. Let's try this again. What if this point that I have, what if it's not on the polar plane, but instead it's on the xy rectangular coordinate plane? I'm still going to use this right triangle. It's just this time I don't know what r and theta are yet. I just know that this is y and this is x. So if I want to try and find r, how would I do that if I know x and y? To find the third side of a triangle, of a right triangle, I can go x squared plus y squared equals r squared. The Pythagorean theorem. And there we go. I put x and y in, and I could solve for r. Okay, but I still need to know what theta is. Well, if I know y and x, what are those in relation to theta? They're the opposite and adjacent side. So I can say tan theta equals y over x. So theta would equal tan inverse of y over x. And there are your conversion formulas to go from rectangular to polar. And you just plug in the y and x that you know and solve for the theta or solve for the r. So now we'll try a few examples with those conversion formulas. Okay, here we go. First, we'll convert from polar to rectangular, and there we have written nicely our conversion formulas. So the first point is 2 comma pi, so that's my r and my theta. Focus first on finding the x value. So x equals r times cosine of pi. And according to our unit circle, cosine of pi out here. So what is the x value there? -1. So it's 2 times -1 gives me -2. And the y value? Y equals 2 times sine of pi. And sine of pi, according to that little visual, is 0. So that equals 0. So the point 2 comma pi corresponds to the point -2 comma 0 on the rectangular plane. If I draw that out, we'll do that for this one. We can visually see that. If I want to plot 2 pi in polar, I'm going to go to pi and then go out 1, 2 units. So I'm right there. And then if I imagine this as the xy coordinate plane, I would go over -2 and then put it right there for 0 for y. So you see it lines up at the same place. Let's convert another. Square root of 3 pi over 6. So x equals square root of 3 times cosine of pi over 6. And that equals square root of 3 times, let's see, cosine of pi over 6. So that's our 30-degree angle here. So it is the point square root of 3 over 2, comma 1/2. So this is times square root of 3 over 2, which is 3 over 2. And then to find the y value, we would go y equals square root of 3 times sine of pi over 6. So you continue to associate sine with y and cosine with x, just like we always do with trigonometry. 1/2. So that is square root of 3 over 2. So we see that this point goes to 3/2, comma square root of 3 over 2 in rectangular. It's really easy to go from polar into rectangular. It's a little bit more difficult to go from rectangular to polar, but we're going to try that out with a few points here. So -1, 1 is the point in rectangular coordinates. So first we can solve for r by doing r squared equals x squared plus y squared. So first we can solve for r by going r squared equals x squared plus y squared. So r squared equals -1 squared plus 1 squared. R squared equals 1 plus 1. R squared equals 2. So r equals the square root of 2. Okay, and then we find tangent of theta because we're trying to find theta. So we do tan theta equals y over x, so 1 over -1. So theta equals tan inverse of -1. So tangent of what angle is -1? Let's see if we can imagine. Because it's tangent of -1, the ratio between the y and the x is the same. So it's going to be a 45-degree angle. And over here, the x is negative and the y is positive. So 3 pi over 4. So theta equals 3 pi over 4. So we have the point square root of 2, comma, 3 pi over 4. Now, is that true? Because there are multiple tangent values that could be -1. For example, I could possibly also have this one, 5 pi over 4. So this is where you have to think about, well, what quadrant is my point -1, 1 in? If I plot -1, 1, I'm right over here. That is second quadrant. So where should my angle be? Second quadrant. So therefore I pick 3 pi over 4 instead of 7 pi over 4 because that would put me in the wrong quadrant. We're going to try another one. We'll find r first. So r squared equals 2 squared plus -2 squared, which gives me 4 plus 4, which equals 8. So r squared is 8, so r equals the square root of 8, which equals 2 square roots of 2, once I simplify that square root. Then we do the tan theta formula. So tangent of theta equals y over x. So theta again equals tan inverse of -1. So is it 3 pi over 4 or 5 pi over 4? Let's think about our point again. So back up on our coordinate plane here. If I want to plot the point 2, -2, I'm going 1, 2, 1, 2, -2 is right there. So I'm going to be in the fourth quadrant. which I should take a moment to correct something I said there. My last point could have been 3 pi over 4 or 7 pi over 4 because tangent is negative in those two quadrants. Tangent is actually positive in that third quadrant. So back to this dilemma, is it going to be 3 pi over 4 or all the way around to be 7 pi over 4? Well, you can see I should be in the fourth quadrant this time because the point 2, negative 2 is in the fourth quadrant. So this time when I take theta, I'm going to say theta equals 7 pi over 4. Or you could say negative pi over 4. Those are both the same, right? 7 pi over 4 goes around. Negative pi over 4 just goes down. So either of those technically work. Let's take the positive value though. There we go. I found my theta and my r. So therefore I know that 2, negative 2 goes to the point 2 square roots of 2, 7 pi over 4. All right, I have one last value to find here. 0, 2. This one we're going to do with common sense because I could plug it into my formulas and figure it out. But it's a little bit easier if we just think about this. 0, 2, where is that? 0, and then I go up 2. That is right there. Let me draw it in light blue. There we go, it's that point. That's the rectangular coordinate. But I think you can think about what that is in polar. What's the r value? It's just 2. You go up 2 units. What's the radian measure of this? Because I'm on the axis, so it's a 90-degree angle measure, or pi over 2. So this is just the point 2, pi over 2. I wanted to throw that one in there because I could use the formulas to get the conversion. Or if it lies on one of the axes, it's really easy to just kind of use common sense to figure out what it is and save yourself some work. So that's how to convert single points from rectangular to polar or vice versa. You can actually use these formulas to convert whole formulas, like maybe the formula for a circle x squared plus y squared equals r squared, convert that into polar. You can use these formulas. And it's pretty simple. But in this video, I just wanted to cover converting single points.